Tell me. Okay. So let me take the, actually it is option 4. How is that exactly? So you know this charge of electron, mass of electron, and mass of alpha particle 2He4, right? So helium is 2He4. And what do you mean by 2He4? There are 2 units of positive charges in helium nucleus and 4 mass units. So therefore, mass of alpha particle will be 4 times the mass of the average mass of neutron and proton, and charge of alpha particle would be corresponding to 2 proton. 2 proton is nothing but, proton also has the same magnitude of charge as that of the electron. So 2 times the electron, but with opposite charge you can write, right? No? Okay. Let's take the ratio. E by m of electron, E by m of the helium. Okay. So E by m, and this electron will be 2 times. And the mass of helium overall you can take. Okay. Mass of helium. It goes to numerator. This is mass of helium divided by mass of electron, and 1 electron get cancelled. Okay. So now tell me, what is the order of mass of helium? It will be order of 10 raised to minus 27 into whatever, into 4, into 1.67, all those things fine. But power of 10 will be 10 raised to minus 27, correct? No? What is the mass of electron? Power is 10 raised to minus 31. If 10 raised to minus 31 go to numerator, how much would it be? Plus 31 and minus 27 would result to 10 raised to 4. Why approximately? Because none of the answers match here. So though Skanda has given explanation something different, but answer was correct. Okay. So the charge to mass ratio of electron to the charge to mass ratio of helium doesn't match in the ratio given. So it will be of the order of 10 raised to 4 is to 1. So therefore, option 4 is correct. Okay. So because mass is 4 times the mass of neutron or proton, so they are approximately same. So it doesn't match. So you can mark option 4 as the correct answer.
Sir, it should be E by M, no, sir?
E by m of electron divided by E by m of helium. You have to take electron as a separate particle and helium as a particle separately. Not the electron from the helium, something like that.
Oh, okay, sir. Thank you.
You have removed helium, the electron from the helium, and you think that there is no electron at all. Why do we need to worry about it? So there are 2 particles here, electron and helium nucleus, like that. Okay. If it is complete, let me know. Is that complete now?
Yes, sir.
Okay. We'll take the next question. If the atomic weight of an element is 23 times that of the lightest element and it has 11 protons, then it contains, okay, so some element, atomic weight of an element is 23, okay, and when it is compared to the lightest element, which is the lightest element in the periodic table?
Hydrogen.
That's all. Compare with hydrogen, and it has 11 protons in it. Now they're asking for the option, the details about proton, neutron, and electron.
Option C, sir.
Okay.
Option C.
Fine. See, when you take, lightest element, it is 1h1. Correct? Now, mass atomic weight is 23. So, mass number can be 23. There are 11 protons, means 11 electron must be there. Am I right? If atomic number is 11, so there should be 11 protons, and equal to that, there should be 11 electrons. How do we calculate neutron? Neutron is equal to 23 minus 11 is equal to 12. So thus, electron number must be equal to proton number always. So option C would be correct. Okay. Shall I proceed now?
Yes, sir.
Fifth one. The compound in which cation is isoelectronic with anion. What do you mean by isoelectronic? Having
The same number of electrons.
same number of electrons. Come on. Cation is isoelectronic with anion. Any idea? Okay. So
I think option 1, sir.
option 1. How many electrons would be there in cation and anion? Potassium atomic number is 19. There are 19 electrons in the atom. But in K2S, which is the ion present? Is it potassium +2 or +1? Potassium is +1 always. So how many electrons will be there remaining in K+? 1 electron would have been removed. So K+ has 18 electrons. Sulfur, what is the atomic number of sulfur? 16. And it is there as what ion? If you see here, it will be 2-. So sulfur 2- has extra electrons. So how many electrons would be there in sulfide? 16 + 2, 18. So 18 electron potassium, 18 electron sulfide. It is balanced. That means they are isoelectronic species. So option 1 is correct. You take any one. Okay, I should explain again. Okay. Listen to me. See, potassium K+ means 1 electron less when compared to potassium atom. You should know atomic number of potassium. Correct, no? What is atomic number of potassium? It is 19. Some up to atomic number 30, all the elements must be known. That is very important. If it is up to 50, that's fantastic. Okay. Minimum mandatory is up to 30 atomic number. All the elements, the sequence, atomic numbers, everything should be known. So potassium, atomic number 19. But this K2S has K+ ion. So that means it would have lost 1 electron. So what is remaining with K+ is only 18 electrons. And sulfur in this K2S is there as sulfide, S2-. Atomic number of sulfur is 16. If it gains 2 more electron, how many electron it becomes now in sulfide? 18. So K plus has 18 and sulfide also has 18. So isoelectronic means having same electrons. So K plus has 18, sulfide also has 18. So both of them have 18 electrons. Therefore, they are isoelectronic to each other. Whereas in Na plus, how many electrons will be there? Can you tell me immediately? Atomic number is 11. Na is plus there. So electron remaining is 10. Chloride, atomic number 17. One electron is gained. So it should be 18. So they're not isoelectronic. So sodium has 10 electrons, Cl minus has 18. So you can take sodium 10 electron. I minus is 54. 53 plus 1. Am I right? So something like that it goes. Come on. CCM and fluorine, no comparison at all. CCM is there at the bottom of the first group, fluorine at the top. Okay. So shall we proceed now? You have to be interactive. When I ask some questions, so you should not expect somebody else to answer. The question is for all the participants here. Okay, either you can use the mode of chat or you can unmute and speak to me. Don't hesitate first. Okay, so you have come here to understand, interact with the teacher, and at the end of the class, there should be some kind of knowledge which has been gained. So without any interaction, if it is absolute silent, one thing I'll not be able to conclude properly. Even if I conclude, it may not be right also. Correct, no? So shall I proceed now? If all of you have completed.
Yes,
Yes,
sir.
sir.
Laila. So someone should respond in the chat box at least. Okay. Sixth one. The number of nucleons in chlorine 37 is?
37.
That's the correct answer. That's all the simple question. Because nucleons means number of particles present in the nucleus. So 37 is the mass number, A. A indicates number of neutrons and protons. So 37 is the nucleus. That's all. It doesn't indicate electrons. Okay. We'll take 7th. I'll just read the question. When atoms are bombarded with alpha particles, only a few in million suffer deflection. Okay. Others pass out undeflected. This is because this is based on Rutherford's alpha ray scattering experiment. So why most of them are undeflected? Only a few in million suffer deflection. What is the appropriate answer for this now?
Option 4.
Okay. The 4 is the nucleus occupies much smaller volume compared to the volume of the atom. Okay. So when you take a volume of the atom, it is much smaller. So very, very few particles can only suffer deflection, and rest all will be undeflected. That's all the thing. Okay, right. So option 4 is the most appropriate answer. Okay. What is the overall radius of the atom actually? 10 raised to minus 10 meter. Whereas the nucleus is 10 raised to minus 15 meter. So that means it is so much small. So therefore, most of the alpha particle goes straight line. Fine. We'll take up next. 8th. The approximate radius of hydrogen atom is 0.05 nanometer. And that of proton is 1.5 to 10 raised to minus 15 meter. Assuming both the hydrogen atom and the proton to be spherical, calculate fraction of the space in an atom of hydrogen that is occupied by the nucleus. Okay, they have given radius of hydrogen and that of proton. So both are spherical. Assume both are spherical. Because volume of a sphere, you know the formula. Using that, you can calculate the fraction of the space that nucleus occupies in hydrogen atom. Can you? So what is the volume of a sphere? Formula.
4 by 3 pi r cube.
4 by 3 pi r cube. So take the 4 by 3 pi r cube of proton, because nucleus of hydrogen atom has only one proton, that's all. One H1. So there is only one proton. That proton occupies what volume? That's all the thing. Volume of atom. So volume of proton divided by volume of atom. You know. Can anybody give me the answer? Let's see. Anybody has got the answer?
Sir, should we divide it, sir?
Yeah,
Sir,
correct.
option 3, sir.
Correct. Calculate the fraction of the space of an atom of hydrogen that is occupied by the nucleus, means proton. Only one proton is there, no neutron at all. So volume of proton divided by volume of atom. That's all you need to do. You know the formula, 4 by 3 pi r cube.
Sir, option 1.
Pardon me?
Option 1.
2.7 into 10 raised to minus 14.
Yes, sir.
Okay. So any other answers? Okay. Shall I take up the solution? Right. Now listen to me. How do we calculate the fraction of the volume occupied by nucleus to atom? To take the ratio, that's all. So volume of proton divided by volume of atom. So volume of a sphere (4 by 3 pi r cube). Okay. So they have given proton has the radius of 1.5 into 10 raised to minus 15 meter, and that of hydrogen atom is 0.05 nanometer. So there also units are different. You should be careful. Okay. Let's substitute here. Volume of proton 4 by 3 pi r is 1.5 into 10 raised to minus 15 meter. Okay. Pi r cube, whole cube you have to do. Right. So divided by volume of atom 4 by 3 pi 0.05 nanometer. 0.05 nanometer. Nano is nothing but 10 raised to minus 9. Minus 9 meter. Okay. 4 by 3 pi 0.05 into 10 raised to minus 9 meter whole cube. Now, this power has to be simplified first, and then you can do. You do one thing. You shift the decimal by one place to the right hand side. Okay, when you shift the decimal to the right hand side, 10 raised to minus 9 becomes minus 10. So that it becomes 0.5 into 10 raised to minus 10 whole cube. What is 10 raised to minus 10 whole cube? Minus 30. When minus 30 go to numerator, that will become plus 30. And 10 raised to minus 15 whole cube is minus 45. So how much would it remain? 10 raised to minus 15 remains in the numerator. Correct, no? And what is remaining? 1.5 whole cube divided by 0.5 whole cube. So that can be written like this. Okay. So you can write remaining ratio like this. Okay. So 1.5 into 1.5 into 1.5. This is 0.5 whole cube, 0.5 into 0.5 to 0.5. So 3 times 3 into 3 into 3 is nothing but 27 into 10 raised to minus 15 is nothing but 2.7 into 10 raised to minus 14 is the answer. So option 1.
So can you please explain again, sir?
Which point you think you didn't understand?
Sir, the substitution part.
That is mathematics of the entire problem. There is no chemistry in that. Correct, no? Okay, let me explain this. See, do you agree this 4 by 3 cancels? Pi cancels. Okay.
Yes, sir.
1.5 whole cube into 10 raised to minus 15 whole cube is minus 45. Okay. This denominator, I would write it as 0.5 into 10 raised to minus 10 whole cube. If shifting the decimal is a problem, then you can use this simple shortcut LIRD like that for shifting the decimal. What is LIRD? If you shift the decimal to the left hand side, you have to increase the power of 10. If you shift the decimal to the right hand side, you have to decrease the power of 10. That's the meaning. Okay. So what is that we have done here? This 0.05. We have shifted the decimal to the right hand side. Decrease the power. Minus 9 becomes minus 10. Okay. No problem. So then apply the power again. It becomes this 1.5 whole cube can be written as 1.5 into 1.5 into 1.5 divided by 0.5 whole cube can be written as 0.5 into 0.5 into 0.5. And this apply the power. It becomes 10 raised to minus 30, right? 10 raised to minus 45 divided by 10 raised to minus 30. If 10 raised to minus 30 go to numerator, it becomes plus 30. Correct now? 3 times, and 3 times. 3 into 3 into 3, 27. If this 10 raised to minus 30 go to numerator, plus 30. So what remains? Minus 15 is nothing but this one. Is that understood? Tell me.
Yes, sir.
Okay, that's fine. Again, shifting the decimal comes, right? Left hand increase the power. Say if a point is here, you are going to shift the decimal here. Left hand increase, minus 15 to minus 14 is power increased. It's a negative value. Hope it is complete. Let me know. I shall proceed with remaining problem. Shall I proceed now?
Yes, sir.
One second. I'll just rub this. Atoms have the mass of the order of. What is the correct answer?
First option.
10 raised to minus 26 kg. Correct, no? Because if you take the neutron, it will be 10 raised to minus 27. And proton of the order of mass, 10 raised to minus 27 kg. Okay, so given atom may have many neutrons, many protons, leaving the small atoms like lithium, helium, lithium, hydrogen and all. Rest every atom will have neutron as well as proton. So put together, if you add the masses, at least it will come in the order of 10 raised to minus 26. So that's the nearest value as per the data here. So option 1. Around 10 raised to minus 26. Yes. 10th question. What is the wave number of yellow radiation having wavelength 5800 angstrom? Answer should be in per centimeter. Wave number, what is the formula for calculating wave number? Wave number is equal to nu bar is equal to 1 by lambda. Come on, get me the answer. Aditya says option 2. How about remaining?
Second option.
Okay. Any others with different answers?
Option 2 only, sir.
Okay.
Option 2.
Right.
Sir, I have one doubt, sir.
Tell me.
Sir, CET li calculator allow ಇರಲ್ವಲ್ಲ ಸರ್?
ಹೌದು, ಇರಲ್ಲ.
ಸರ್, ಈಗ 17 ಡಿವೈಡೆಡ್ ಬೈ 5800 ಮಾಡಬೇಕು ಅಂದ್ರೆ ಟೈಮ್ ತಗೊಳ್ಳಲ್ವಾ ಸರ್?
ಇಲ್ಲ, ಅದಕ್ಕೆ ಹೇಳ್ತೀನಿ ನೋಡಿ. ಈಗ ಐ ಡೂ ಇಟ್. ಓಕೆ, ಅಪ್ರಾಕ್ಸಿಮೇಷನ್ಸ್ ಮಾಡೋದನ್ನ ಸ್ವಲ್ಪ ನಾವು ಬೇಗ ಕಲ್ತ್ಕೋಬೇಕಷ್ಟೇ. ಸೊ ನ್ಯೂ ಬಾರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 ಬೈ ಲ್ಯಾಂಬ್ಡಾ. ಲ್ಯಾಂಬ್ಡಾ ಎಷ್ಟಿದೆ ರೀ? 5800 ಆಮ್ಸ್ಟ್ರಾಂಗ್. 1 ಆಮ್ಸ್ಟ್ರಾಂಗ್ ಇಸ್ 10 raised to minus 8 centimeter ಆಗುತ್ತೆ. ಇಸ್ ದಟ್ ಓಕೆ? ಸೊ ಇವೆಲ್ಲ ಕನ್ವರ್ಷನ್ಸ್ ಎಲ್ಲ. ಸೊ 1 ಆಮ್ಸ್ಟ್ರಾಂಗ್ ಇಸ್ 10 raised to minus 10 meter. Okay, 10 raised to minus 10 ಅಲ್ಲಿ you take out minus 2 out, becomes 10 raised to minus 2 meter. Is that okay? So what is 10 raised to minus 2 called? Centi. So 1 Armstrong would be equal to 10 raised to minus 8. This is centimeter. No problem. So 5800 Armstrong is nothing but 5800 into 10 raised to minus 8. That minus 8, when it go to numerator, it becomes plus 8, or you shift the decimal here itself. So it becomes 1 by 58. When you shift the decimal, left hand, increase the power. How many positions are you shifting the decimal? 2 positions here. So minus 8 becomes minus 6. Now you push the 10 raised to minus 6 to numerator. It becomes 1 by 58 into 10 raised to 6. In 10 raised to 6, you take out 100 so that you can divide easily. So take out 10 raised to 2 outside. That means 100. What remains is 10 raised to 4. Now tell me, what is 100 by 50? Not 58. I'm asking 50. 100 by 50. 2. 100 by 58 will be less than 2 into 10 raised to 4. That's all is your answer, no? You need to get 1.7 exactly. So 1 by 50 is 2. 1 by 58 is less than 2. Less than 2 into 10 raised to 4, you have to search for the answer. Option 2 is the correct answer. 90% of the problem will work out like this. Remaining 10% where answers will be given in terms of matching type, right? Like for example, 1.7 in 10 raised to 4. Next option will be 1.8 into 10 raised to 10 raised to 4. Or another option will be 1.75 into 10 raised to 4. Very rarely they do like that. Very rarely. When answers are of matching type, very close by answers, then exactly you have to calculate. Otherwise, approximation is enough. Is that okay, Skanda?
Yes, sir.
Yes. Come on, work out this now. Let me know if it is complete. ಅದನ್ನೇ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ತಾ ಮಾಡ್ತಾ, ಸೊ ವೆನ್ ಯು ವರ್ಕೌಟ್, ಈಗ ಇಲ್ಲೇನೋ ಒಂದು ಕ್ಲಾಸಲ್ಲಿ ಒಂದು 40 ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡಿದ್ರೆ ಇಂಟು 10 ಟೈಮ್ಸ್ ಮಾಡ್ಬೇಕು. ನೀವು ಎಷ್ಟು ವರ್ಕ್ ಹೆಚ್ಚಿಗೆ ಮಾಡ್ತೀರಿ ಅಷ್ಟು ಸ್ಪೀಡ್ ಇಂಪ್ರೂವ್ ಆಗುತ್ತೆ, ಅನಾಲಿಟಿಕಲ್ ಸ್ಕಿಲ್ಸ್ ಇಂಪ್ರೂವ್ ಆಗುತ್ತೆ, ಅಂಡ್ ಪರ್ಸಿವರೆನ್ಸ್. ನೀವು ಪ್ರಾಬ್ಲಮ್ ನೋಡಿದ ತಕ್ಷಣ ರಿಲೇಟಿಂಗ್ ಟು ದಿ ಪ್ರಾಬ್ಲಮ್ ಅಂಡ್ ಪಿನ್ ಪಾಯಿಂಟಿಂಗ್ ದಿ ಸೊಲ್ಯೂಷನ್ ಫಾರ್ ದಟ್ ಈಸ್ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್. ಅದೇ ಕ್ವಿಕ್ನೆಸ್ ಬರಬೇಕಾಗಿರೋದು. ಸುಮ್ಮನೆ 40 ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದ ತಕ್ಷಣ ಬರೋಲ್ಲ, 100% ಬರೋಲ್ಲ. ಅರ್ಥ ಆಗುತ್ತೆ ಅಷ್ಟೇ, ಓ ಇದು ಹಿಂಗ್ ಮಾಡ್ಬೋದಾ, ದೆನ್ ದಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಇನ್ಕಲ್ಕೇಟೆಡ್ ಇನ್ ಯು. ಅದು ಸ್ಪೀಡ್ ಆಗ್ಬೇಕಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ವರ್ಕ್ಔಟ್ at least 10 times more. That's a good number actually. 5 times is what is basic requirement. 10 times ge ನೀವು 400 questions work ಮಾಡಿ atomic structure. So definitely things will improve a lot. ಅದರಲ್ಲಿ ಎರಡು ಮಾತು. Right pa? Shall we proceed? ಆಯ್ತಾ ಇದು?
Yes, sir.
Right. 11th, a photon of wavelength 1240 angstrom strikes a metal surface. Ejected a photoelectron with kinetic energy E. The work function associated with metal is 4 electron volt. The value of kinetic energy E. Work function is threshold energy. So Nikita, 11th option 2, 6 electron volt. Okay.
Yes, sir.
Okay. How about remaining?
Option 2, sir.
Fine. Anybody has got any other answers? Did you all work? ಮಾಡಬೇಕು, ಟ್ರೈ ಮಾಡಬೇಕು. Okay, so let me take the answer, solution for this. See, the incident energy always, actually the photoelectric effect equation ಏನದು, energy that is incident is equal to threshold energy plus kinetic energy. So incident energy is equal to threshold energy. Threshold energy is nothing but work function W. So incident energy is equal to W plus K, kinetic energy. So energy is nothing but what? H nu. So it can be taken as incident energy is H nu is equal to work function. They have given 4 electron volt plus the kinetic energy is given to be. You need to calculate this kinetic energy itself of the. Let's substitute remaining. H nu is what? Nu is nothing but C by lambda is equal to 4 electron volt plus E. Am I right? Now let us substitute and simplify further. Come on. So if you simplify this further, one second. Substitute for H. H is 6.626 or 625 into 10 raised to minus 34. Okay. Into C, velocity of light, 3 into 10 raised to 8. Divided by wavelength they have given. 1240 Armstrong means 10 raised to minus 10 meter. And do we need to convert this joule into electron volt? Because the work function is given in electron volt. So if you want to convert Hc by lambda, it will be in joules. You have to divide by 1.602 in 10 raised to minus 19. Okay. So then it will convert to electron volt. You simplify this now. First power, let us simplify. 10 raised to minus 10, 10 raised to minus 19 in the denominator would be how much? 10 raised to minus 29. If 10 raised to minus 29 goes to numerator, it will be plus 29. Okay. So I think I have to write here. I'll just write the ratio enough. Denominator 10 raised to minus 29. Numerator minus 34 is there. 10 raised to minus 34. And 10 raised to 8 is there. So it becomes 10 raised to minus 26. If it goes to numerator, it becomes 10 raised to minus 26 into 10 raised to plus 29. How much is that remaining? 10 raised to 3 in the numerator. Or that too, you can shift this decimal 1240. If you shift the decimal to the left hand side up to here, 1.24, then it becomes 10 raised to 3. The 10 raised to 3 and 3 cancels. So finally, you can get the ratio reduced to this form. Okay. See, these are all mathematical steps. So there is no chemistry as such. Okay. I think.
Why did you multiply with electrons, sir? Charge of it.
Come again, once again. I didn't understand.
Sir, why did you multiply with 1.6 into 10 to the power of minus 19?
That's because we need to convert electron joules into electron volt here. What is 1 electron volt is equal to? Anybody? I just now told. 1 electron volt is
1.6 into 10 power.
1 electron volt is equal to 1.602. You can leave that 02. 10 raised to minus 19 joules. So joules into electron volt you have to do. So therefore 1 joule is equal to 1 divided by 1.6 into 10 raised to minus 19 joules. So you have to divide the entire Hc by lambda ratio with 1.602 in 10 raised to minus 19. Is that okay, Skanda?
Yes, sir.
Okay. If you want, I can work out completely in detail. So is it required, anybody?
No, sir.
So there is little more requirements of mathematical skills, as I feel. Okay. Somebody says yes, sir, here. Let me work out this problem in detail. Listen to me now. Forget about these steps. E is equal to E naught plus Ke is the equation of photoelectric effect. E naught is threshold energy, nothing but work function. E naught, they have given 4 electron volt. Kinetic energy, they have represented as E. Sorry. Kinetic energy has been represented as E. Okay, let me go on. E is equal to E naught plus kinetic energy. E is nothing but h nu. E naught has been given as 4 electron volt. Kinetic energy, they have represented just E. What is h nu? Nu is nothing but C by lambda is equal to 4 EV plus E. Okay. Let's substitute the values. So here you should know we are going to convert this left hand side will be in joules. Sorry. So this 1 joule should be equal to 1 divided by 1.602 into 10 raised to minus 19 electron volts. So this is the conversion you should know. So let's substitute for H, C and lambda. 6.626 into 10 raised to minus 34 into C is velocity of light 10 raised to 8 divided by what is wavelength they have given I'll write it separately here. See, wavelength given is 1240 Armstrong, or 1240 into 10 raised to minus 10 meter. Is that okay? Now, or else you can also do like this. You shift the decimal 1.24 into 10 raised to how much? Minus 7. It will. Okay. Shift the decimal to the left hand. Left hand side, increase the power. We are going to shift the decimal 1, 2, 3. So 1.24 into 10 raised to minus 7 it becomes. So let me write lambda 1.24 into 10 raised to minus 7. Into that conversion, 1.602 into 10 raised to minus 19 is equal to 4 electron volt plus kinetic energy E. Okay. Now left hand side is also in electron volts. Let's simplify the parts now. 6.626 into 3 divided by this 1.24 into 1.602. What about remaining powers? 10 raised to minus 7, 10 raised to minus 19 will be 10 raised to minus 26. Okay, into what is there in the numerator? 10 raised to minus 34. 10 raised to 8 will be how much? 10 raised to minus 26 into what is there in the denominator now? 10 raised to minus 26. If it goes to numerator, it becomes plus 26. This to get cancelled. So the ratio finally reduces to 6.626 into 3 divided by 1.24 into 1.6. Correct, no? So can you finally tell me how much this reduces to?
10.
It will exactly reduce to 10. Okay. Correct, no? So you can see here this 1.2. Okay, it goes by 3 change, 3 point something. So numerator will be 9 point something divided by, am I right? So this is 1.6. Sorry, it is 6 times, not 3 times. It is 6 times. 1 point, correct, no? 6.625. Approximately 1 point. It is around 6, no? 6 or less than 6. Let's say 5 point something. Okay. So 5 point something into 3 is, it goes by 15. 15 point something divided by 1.6 is approximately 10 times. Well, right now. So 6.626 divided by 1.24 is 5 point something. 5 into 3 is 15 point, little more. Numerator is greater than 15. That's all. Denominator is 1.6. So numerator is 15 and denominator is slightly greater than 1.5 is approximately 10. Is that okay? Now left hand side is 10 is equal to 4 plus kinetic energy. Therefore, what is kinetic energy? E is equal to 6 EV. 10 minus 4. Come on. Now, if anybody has any problem, you can ask me, no problem. Any doubts?
No, sir.
Oh. Shall I proceed to next problem? If it is done. This is approximate simplification. Otherwise, it takes time. Is it done, all of you?
Yes, sir.
Okay.
Yes, sir.
Fine, thanks. I'll proceed. So it is option 2. Let me remove this, whatever I have written. If all of you have copied down, I'll just remove this, whatever I have written. Okay. Yes. 12th question we'll take. Which of the graphs shown below does not represent the relationship between incident light and the electron ejected from the metal surface? Come on. Aditya, what is this? No, sir. Nikita is option 3 or 4?
3, sir.
Okay. Okay. See, let us find how exactly photoelectric effect takes place. So it is the phenomenon of ejection of electron from a metal surface when a radiation of suitable frequency incidents on the metal surface, correct? No? So with a very frequency that incident on the metal surface, electron may not be removed. There is a suitable frequency required, that is what is threshold frequency, correct? No? So in option 4, what has been plotted here? Kinetic energy versus energy of the light, that is photon. So after some gap, the electron started ejecting. When energy increases, kinetic energy of the ejected electron also increases. So this point corresponds to threshold frequency nu naught or threshold energy E naught, anything. Is it okay? So if fourth graph is correct, they're asking about does not represent. Kinetic energy plotted against energy of the incident radiation. If this fourth graph is correctly representing photoelectric effect, can this third be correct? If fourth is correct, taking kinetic energy along x-axis and same energy, frequency is nothing but energy. Energy along x-axis and the kinetic energy along y-axis. If fourth is correct, third should be wrong, no? So option 3 is the right answer.
Sir, can you explain it again, sir?
Okay. See, man. See, problem is that's why yesterday I have posted one video also. So looking at this, you people, have forgotten the concept probably. This is metal. When you forget the concept also, then it becomes very delay. No problem. I will keep explaining. So what would happen? Number of questions covered per class will decrease. Now look at this. This is a metal. When a radiation of suitable frequency, which is represented as E naught. E naught is nothing but H nu. For suitable frequency, H nu naught we say, that is called threshold frequency. The electron is emitted. Okay, this electron emitted is photoelectron. So when you plot the energy, kinetic energy of the electron versus the energy of the incident radiation or frequency, you will get this kind of graph. This is correct. Okay, if this graph correctly explains the photoelectric effect, you can see here after 0 point, we have moved up to this point along x-axis. What does it mean? So energy of the incident radiation has to be sufficient enough. It has to be more. It is not starting from 0. So for a particular frequency, nu naught only, electron is removed. It means this is nu naught position or threshold frequency. Beyond that point, electron ejection starts. When energy increases beyond that point, kinetic energy also increases. So this graph, fourth graph, is correct about photoelectric effect. If fourth graph is correct, third graph is correct or wrong?
Wrong, sir.
That's all the simple common sense, right? If fourth is correct, third is wrong, like that. Because for what does for third graph indicate? For a very frequency of radiation that incident on the metal surface, electron starts emitting. You can see the graph has started. So it doesn't mean electron can be emitted from the zero frequency also. It is not possible, no? For a particular frequency only electron emits from the metal surface. So if fourth is correct, third is wrong. And remaining two are correct because number of electrons emitted from the metal surface, okay, does not depend on the frequency. That's why it depends, it is parallel to x-axis. Number of electron doesn't increase. Similarly, when intensity of the radiation increases, and the intensity of the incident radiation increases, it only increases the number of electrons removed, not the kinetic energy. So when you plot kinetic energy versus intensity, kinetic energy doesn't change with intensity, only it changes with frequency. So it is a parallel line, parallel to x-axis. So 1 is correct, 2 is correct, 3 is wrong, 4 is correct. So they're asking about which does not represent correctly the relationship. So option 3 is right. Okay.
Yes, sir.
ಈಗ ಐ ಜಸ್ಟ್ ವಾಂಟ್ ಟು ಟೆಲ್ ಯು ಸ್ವಲ್ಪ ಒಂಚೂರು ಫೀಡ್ಬ್ಯಾಕ್ ತಗೊಳ್ತೀನಿ. ಅಂದರೆ ನೀವು ಹೆಂಗೆ ಓದ್ತಾ ಇದ್ದೀರಿ, ಏನು ಮಾಡ್ತಾ ಇದ್ದೀರಿ ಅಂತ ನೋಡೋಕೆ, ಆಯ್ತಾ? ಸ್ಟೂಡೆಂಟ್ಸ್, ಈಗ ನಿಮ್ಮ ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸಸ್ ಎಲ್ಲ ಲುಕಿಂಗ್ ಅಟ್ ಆಲ್ ಯುವರ್ ಶೆಡ್ಯೂಲ್ ಅಂಡ್ ಎವ್ರಿಥಿಂಗ್, ಡೈಲಿ ಟೈಮ್ ಎಷ್ಟು ಸಿಗುತ್ತೆ ನಿಮಗೆ?
1 hour or 1.5 hours, sir.
My God. Right. Sometimes it doesn't respond. Okay. I think this is done. 12th problem is okay. No problem. That's all the thing. Okay. We'll take up 13 now. The radiation of low frequency will be emitted in which transition of hydrogen atom? Low frequency indicates energy. So radiation of low frequency, low energy is emitted in which of the transition of hydrogen atom? Come on. What are the
Option.
Pardon me?
Fourth option.
Fourth option.
Fourth option.
So what is the reason?
The energy difference between two consecutive lines will be less, and energy is directly proportional to frequency.
That's all correct. So here you can see the delta E is the energy. Okay, so delta E, that means difference in energy is emitted as light photon in the spectrum, actually hydrogen spectrum. And if you remove this constant, this energy emitted is directly proportional to frequency. So if difference in energy is more, frequency emitted is also more. You can see here, this is N1 to N4. So it should be E4 minus E1. So difference is more. This is E5 minus E2. This is E3 minus E1. Whereas this is only one difference is there. This corresponds to energy of 5th energy level minus 4th energy level. So difference is very less here. So this corresponds to low frequency, low energy radiation emitted. ಇನ್ನು ಕ್ಲಿಯರ್ ಆಗಿ ನಿಮಗೆ ಹೇಳಲೇಬೇಕು ಅಂದರೆ ನೋಡಿ, ಇದು ಆಟಮು ಫಸ್ಟ್ ಎನರ್ಜಿ ಲೆವೆಲ್, ಸೆಕೆಂಡ್ ಎನರ್ಜಿ ಲೆವೆಲ್, ಥರ್ಡ್ ಎನರ್ಜಿ ಲೆವೆಲ್, fourth energy level, like that, fifth energy level. So when electron transits from one energy level to another energy level, it emits energy. So here n is equal to 5 to n is equal to 4. This is fifth energy level, this is fourth energy level. Electron just has fallen from 5 to 4. The difference in energy is too less. So the frequency of the emitted radiation is also less. That's the meaning. Whereas from 4 to 1, okay, this is 4 to 1, the energy is more. So 5 to 2, so this is 5 to 2, energy is more, something like that. So difference, it will be very less with option 4. I'll just remove that. Okay. So you can take this frequency directly proportional to energy, which is in turn directly proportional to difference in energy. So difference in energy is very less in option 4. Okay. 14. The first emission line in Balmer series of hydrogen spectrum will have the wave number. So it is in per centimeter they're asking. Wave number is per centimeter. Okay. The
Sir,
first
option
emission
one.
line. Tell me.
Option 1.
Option 1. What is N1 and N2?
Sir, N1 is 2 and N2 is 3.
Very good. That is called H beta, H gamma. What is line? What line is that?
That is Balmer series. First one is N1 is 2, sir.
That is called H alpha line.
Okay, sir.
H alpha line, right? So for Balmer series, right? Okay, for Balmer series, lower energy level must be 2, and first emission line means N2 should be 3. The equation, Rydberg equation is nu bar is equal to Rydberg constant into 1 over N1 square minus 1 over N2 square into Z square. For atomic number of hydrogen, 1 square. So that will not be. So let's substitute for R. Answer is given in terms of R itself. Okay. So let me write here. RH into 1 over N1 is 2. 2 square is 4. Minus 1 over 3 square is 9. That's what it's been written here. Okay. Now what are the LCM? 36. Numerator 9 minus 4. 5 by 36 times the R. Correct? That's all the thing. So 5 by 36 times the Rydberg constant RH. They have given it as R. So option 1 itself is correct. Let me know if it is done. Shall I proceed now?
Yes, sir.
Yes, sir.
Okay. 15th questions will. Let me erase this. Okay. What are the values of N1 and N2 respectively for H beta line in Balmer series of hydrogen spectrum?
Third option.
Pardon me?
Third option.
Okay. See, there are 4 prominent lines of Balmer series. Bright lines, what we call. Okay. So because Balmer series is the only visible series of hydrogen spectrum, in that visible lines, there are 4 lines which will be very bright. So 4 bright lines or prominent lines of Balmer series. Okay. So they are H alpha, H beta, H gamma, and H delta, like this. Okay, N1 and N2 values will write N1 and N2. Okay, for H alpha, for any line for N1 is 2 because they are Balmer lines, like that. N2 will be, so this is 3, this is 4, this is 5, this is 6, which means when electron falls from third energy level to second energy level, it gives H alpha. Fourth energy level to second energy level, it gives H beta. Fifth energy level to second energy level, it gives H gamma. And sixth to second, it gives H delta. So they're asking about H beta. H beta is this one. 2, that means 4 to 2. Don't worry about this arrow mark. Actually, it is from 4 to 2 is what is N1 and N2 should be 2 and 4. Is it complete now? So that's fine. It's already 9:31. Okay. What we'll do, we'll stop at this stage, and remaining questions of this part will continue in the next class. And in the next class, we'll take up the remaining portion of structure of atom also. Okay. Bye-bye. Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Sir, I wanted to ask something, sir.
Srihari, tell me.
Yatin, sir.
Pardon me?
This is Yatin, not Sri.
No, little louder. I'm not able to hear you.
I wanted to ask you about this app login details, sir.
Okay. Still, I think you people have not been given no app details and all.
Yeah,
No,
sir.
sir,
That's
we
what I
have not
wanted
been
to
given.
ask. Like,
Ah,
that
yeah,
will
yeah.
help us in revision
No,
between
no.
these
Thing
two
is,
platforms.
this admission process and all still it is happening actually for your batch. If once we freeze the numbers, then we'll be able to give. We'll see this week it can be done.
Yes, sir. Thank you.
Okay. We'll see to it that to this week we'll do that. Okay. To by the end of the week, at the most, you will get it.
Thank you, sir.
Thank you. Thank you. Yeah.
Thank you, sir.
Thank you, sir.
Yeah. Bye. Right.